This is section 2.2, day 2, and we're going to continue our polynomial functions of higher degree. Today we're going to talk about kind of the middles of the graph. Yesterday in previous lesson we talked about the end behavior, and now we're going to talk about what's kind of happening in the middles. So the multiplicity of a zero is actually the number of times the zero appears. And I'll talk you through what that means. So sometimes we have a zero that happens only once. Each of these happen one time. This zero actually happens twice. Remember that squared means that you have two of them. And this zero happens to happen 3 times. So those are the 3 different scenarios that can happen, and then along with higher powers. So we'll talk about that. This first one, we have a 0 at 2, and we have a 0 at -1. So we have a 0 at 2 and a 0 at -1. Then we know this is a parabola. If I were to FOIL it, I would end up with an x squared. There's no negative in front, so we know that this has to open up. In all the other work we have done, we could figure out what the vertex is. Right now we're just kind of talking about each of these zeros and that they show up one time. What I call this, when they only cross the x-axis once, I just call that a cross. And this works for any power of 1. Or if the 0 shows up one time. When the 0 shows up twice, what happens there is, so this 0 is at 2. We don't graph it again, but at that 0, what happens is it doesn't cross through it and heads to the other side of the y or x-axis. It hits that 0 and then it bounces right back. So we call that one a bounce. And that works for any even power. So squared to the 4th to the 6th. That's the behavior that happens at that 0. So it kind of comes through, it hits that 0, and it bounces back. Different than crossing straight through the 0. These ones bounce off. The third one is what happens when you have a cubed or a fifth or any kind of even power. It actually acts like kind of a mini cubed function right on that point. So this is a 0 at 2 again, and it's positive, so our normal function is going to start at the bottom, and when it gets to this 0, it's going to kind of like snake through it before continuing on. So it doesn't cross straight through like this one. This one just went bam straight through. This one bounced off the 0. This one kind of comes in, levels out for a hot second, and then it keeps on going. So these we call snakes. They kind of snake through their value, or their 0. And this happens for any odd powers higher than 1. Because if it's a 1 power, or a power of 1, then it goes straight through, or it crosses. And that's what we're going to be dealing with today, is all of our multiplicities and how they would look on a graph. So first one says, can you write a polynomial function with the following zeros? Well, if I know that is a 0, then this has to be the factor. Oops, sorry, that's a 2, not a 3. If that's a 0, then that has to be the factor. If that's a 0, then I could write this again as the factor. Or I could write x with the x minus 3. I could just write that twice. Sorry, my light just shut off. There we go. And I could just write it twice. So either of these will do. I'll just throw an equal in front and then an f of x just to keep us very mathematically sound. Okay. And then the next one we've got is we're just going to sketch the graph of this guy. So first step is end behavior. We're going to look at the highest power. It's a cubed. We're going to decide that it is positive. So this is a down-up behavior. So I'm going to throw a down and an up on my graph. Factors are next. Can't factor a cubed, but I could take out what they have in common, which is a squared. Oops, that's a 2. And it would leave me with an x minus 2. Now those are my factors. So my zeros then are 0 and positive 2. Their multiplicities, this 0 showed up twice. It had a power of a squared power, because that's the same as this, so that's where the show up twice idea comes from. So this is a bounce. I'm just going to put a b below it. And then this 2 just showed up once. It has a power of 1 there. We just don't write it. But it only visually happened one time, so that will be a cross for us. So I'm going to put a 0, I'm going to put a dot at 0, and I'm going to put a little b there so I don't forget as I go to graph this that I have to bounce there. And then on the second one at 2, that's actually a cross, so I'm going to put a c there. So now as I attempt to connect them in order from left to right, as this graph comes up, I'm going to touch this 0 and bounce back. And then at some point I have to turn around to come back and get this guy. I got to hit that. So I got to go right through this x-intercept. So I'm going to go right through it and cross right through and pick up my other arrow. So as you put these pieces on there, your end behavior, your zeros with your multiplicities, and you start to graph, if something kind of doesn't match up, make sure that you go back and check, because that might mean maybe your end behavior is incorrect, or you have a bounce or a cross or a snake mislabeled. But all of those pieces come together to make one graph. Not super concerned with how deep this dip is right here. Like if yours went lower or went shallower than mine, that's okay. I'm focused on the multiplicity at the zeros and your end behavior, putting all that together. So here's the next two. We're going to do kind of one where we're going to graph it, and then we'll do one where we write an equation for it. So this first one to graph, they've got it all factored out for us, which is really nice, so I don't have to do that part. So my zeros are easy to find. I have a 0 at 3, I have a 0 at -2, and I have a 0 at -4. Much easier to find when I don't have to do the work. This 0 was squared, so that's a bounce. This one had a 1 on it, so that's a cross. And this one had a 5, so that's a snake. Now we need to figure out our end behavior. Our end behavior is not x to the 5th because there are more x's in this function. So if that was FOILed out, it would be x to the 5th. This would be another x, and this would be an x squared. So altogether, I'm actually x to the 8th. I've got 5, 6, 7, 8 of them with a negative in front. So the end behavior for this function, highest power being an 8, and negative means I'm a down and a down. So now when I go to connect them, I'm going to come up to this first one and I'm going to snake through it. So I'm going to come up kind of short of it, snake through, and then continue. I have to turn around to come right, oops, my hand's in the way. I have to turn around to come right through this cross here, so I'm just going to cross right through that 0. Continue on. I have to turn, I'm going to have to bounce right off that one and come back to pick up my other end behavior. Last one, we're going to write a possible equation for this graph. So I'm going to start off by doing an f of x. My first 0 happens at -3, so that means it's a +3. Next I've got -1, so that's a +1. And lastly I've got +2, which will go in as -2. Now we need to look at our multiplicity. So this one went straight through, so that's a cross. That's just a power of 1. This one kind of snaked through, so that's a power of 3 or any other odd power. And then this one is a bounce, so that's any even power you choose. I'm just going to pick a 2. Last one we got to check is our end behavior. Looks like we're an up and up, so that's a positive parabola. I'm just going to add my powers together real quick, make sure that they end up being even. So 1, 4, 5, 6 looks good. I ended up being an x to the 6th positive, so that matches with my end behavior. So today is taking our end behavior, that idea, and then combining it with the idea of multiplicity to complete our graphs.